Well, hello there. Welcome or welcome back. We're going over some of the airframe items. This subject, position and warning. Moving on to stall warning. What is a stall? It's caused by the separation of airflow from the wing's upper surface. This results in a rapid decrease in lift. Lift is the airflow above the wing, which actually causes the wing to rise. If there is no there is no air there, certainly you're not going to have any rise. If anything, you're going to have the opposite. For any given or particular airplane, a stall always occurs at the same angle, regardless of airspeed, flight attitude, or weight. This angle is the stalling or the critical angle of attack. Uh, when the wing is nearly stalled, the upward airflow moves the vane to activate the stall warning. Okay, we're talking about the stall warning vane pictured here to the far right. Um, and you can see the little vane at the tip of the leading edge of the wing, and it is attached to the unit, which you can see a larger version here. This is a popular one. You'll see it in most aircraft. You might have to look around in the hangar to find one that we have, but you will locate them. And you can kind of see how it works. If you're traveling normal, um, the tab is going to be held down, and you can't really see the tab much in here. It's right in this part because the wind is keeping it down. But as soon as it goes up, um, or as soon as your pitch increases, then the relative wind is going to shoot it back, and it's going to warn you with a buzzer sound. More of the same, the tab type. This one you can see it doesn't actually have a tab. So if you notice that, no, the tab's not missing. It's just using a different method to detect the stall. It's a reed. In effect a reed that's placed on the inside. So it's kind of like a reed instrument, musical instrument. It utilizes a reed which reacts with the wind. Um, you can't see it. It's located behind this opening in the leading edge of the wing. When the angle of attack increases to near the point of a stall, low air pressure flowing over the opening causes a suction which audibly vibrates the reed. So in effect, the when you get to a certain angle, the air doesn't really flow into the chamber there. It it flows over it, which in effect creates this suction, which is drawing air out of that little chamber, and that's what's causing the reed to vibrate. This looks like a 747. Basically, there's a test button, so you can see the stall warning. Um, it's got up for test, and in that case, the air-ground relay is bypassed, the stick shaker operates, the black and white test indicator rotates over here, and the system checks the angle of attack vane and flap position sensor. So the test does a number of things on the 747, which you can imagine it would. We did see that there's a shaker stick, so not only do you get an audible reading, but pilot's stick starts shaking, and you're going to see this black and white circle start to rotate. So a lot of different visual warnings, or tactile and visual. 737, the most common aircraft, its warning system. You can see how a stick shaker works. It's basically hooked to the column of the yoke, and it's a little motor that's got an eccentric cam attached to it, which in effect, as it circles, it's shaking the motor. It's shaking the shaft. What else do we see? We see a block diagram with a number of inputs going into a digital stall warning computer, which does send out a signal to the display through the symbol generator. What goes into it? Do we need to know all this? I don't think so. Certainly flap position, the vane, if one is installed, the speed of the two different parts of the turbine engine, the air ground relay to make sure you're not on the ground, and certainly the air data computer. A question: stall warning systems are generally designed to begin warning the pilot when a stall A is imminent, B is starting to occur, or C first affects the outboard portions of the wings. All good responses. To be most precise, though, the FAA prefers the imminent word. So when a stall is imminent, that's how they are designed. You want to basically get it before it actually starts to occur, whether it's starting to occur or starting to occur on the outboard portions of the wing. You'd like to get it a little quicker, and imminent, it means that it's not quite, it's approaching, it is very close, but it has not yet arrived. Imminent. That way the pilot has a chance to make some move before the stall actually occurs. Because afterwards, it's a different move. Another question: the pneumatic or the reed type stall warning system installed in some light aircraft is activated by what? Was it static air pressure, positive air pressure, or negative air pressure? Well, we saw that the reed type is actually affected by the suction caused when the wing is pointed in a stall position, because the relative wind doesn't actually enter the chamber, and that suction would be negative air pressure. They call it a pickup hole. By what usual means does the stall warning system in a small aircraft alert the pilot of an impending stall. See, there's our word impending, or imminent, I'm sorry, a different word. Basically the same. All right, so what usual means does it alert the pilot? Well, it could have that shaker stick, um, and most frequently you'll hear a horn, and you'll also get a light flashing. So I'd say those three answers should be enough. Two is plenty. The audible alert and or a warning light, which is what it is in most small aircraft. They're not going to have the shaker stick. Very closely related to stall is the angle of attack system, because certainly if you get beyond your angle of attack for that aircraft, you'll create a stall. So it's very, very closely related. Well, I'm not. This is kind of what it looks like. This is out of one of the old um, ACs. At least that's what it appears. Yes, the figure. This looks like a newer illustration. Um, as the angle of attack changes, the amount of air entering the angle of attack sensor changes. Uh, it's similar to the relative wind going into the pickup hole for the pneumatic stall warning device. Only this one is different. It doesn't have a reed inside it. It's got little paddles, which actually are moved by the wind. And depending on how far they move, it's attached to a potentiometer, which is similar to a rheostat, where you can adjust the amount of current and therefore the speed. Varies the current to the indicator. Okay, to the indicator, which would be down here. That in turn gives an indication of the angle of attack. Not a common instrument, but you have to cover it. And this seems the best place. It's close to the stall warning, so the concepts and the words are going to be very similar. Angle of attack, imminent, impending. There's a little close up. It can be adjusted. Looks like it would be this little screw over here that do the adjustments. If that's not a mounting screw, it would have to be a mounting screw based on the other empty ones. Not exactly sure. Okay, the angle of attack is just words. It's not really, you're not going to get to that area. So the pointer is pointing at this point. Apparently, what do we have? 10, 11, 12, 13, 14 point something degrees. It looks like a flag's here. The internal structure of a slotted probe airstream direction detector. A little closer look at those paddles. And the actual potentiometer is illustrated here by the coil and a wiper that's pointing to a certain part of the resistor. And the more this is being pushed, the more the resistance is being taken off of the circuit, which goes to the indicator through a simple generator. I don't think there's anything else here. All right, I get it. It's not necessarily the wind that's coming through any part of this area. This is all enclosed. The actual slots are off here, so I think the only thing that's in the airstream is this probe. You can tell, like I mentioned, you don't see these instruments that often, so I don't think we have one to actually show you if it's not in just in a parts collection. They do mention a pressure differential. I don't think you have to worry too much about that. A vane type sensor, no, this makes a little more sense. The vane goes up depending on where your angle of attack is. You can actually visually, it's like a small aircraft in effect. And I guess many large aircraft use that type. Here's a slotted angle of attack probe and an alpha vane. All right, so it's the larger aircrafts that might have that, what they call it, the vane type. That would be on the right here. So they're showing the equivalency of it. The airflow is going through, and the air holes are being moved, or the vane is being moved. And the question is, the angle of attack detector operates from differential pressure when the airstream blank. So I guess we do have to worry a little bit about differential pressure. Okay, so when the airstream is A, parallel to the longitudinal axis of the aircraft, B is not parallel to the true angle of attack of the aircraft, or C is parallel to the angle of attack of the aircraft. All right, so this one you have to think a little bit about. So there's going to be a differential pressure when that airstream that's coming in. Is that going to be parallel, running the same direction as the long axis of the aircraft from the nose of the aircraft to the tail? No, because that's actually the way you're going to normally travel. How about if that airstream is not parallel? Well, I think that's a pretty general statement of when it's going to operate, whenever that air is not going to be where you would expect it to be. You would expect it to be parallel, so is not parallel is going to be my answer. Is it my final answer? C is parallel to the angle of attack. Again, this is parallel to the aircraft, which is the same as A in effect. So it's going to be B. It does that differential is it does that by finding the angular difference between the direction of the local airflow and the fuselage reference plane. I know you guys probably don't care that much about that, but the fuselage reference plane. Some fill in the blank questions. I used to do this quite a bit. You could tell this is an older presentation. Just the formatting and everything is so different. And I just figured leave it this way. There's no sense of updating formatting because it's not terrible. So let's look at question 34. The airspeed of an airplane is or is not always an indication of an impending stall. Now, we did see that a stall, it doesn't matter your speed, your attitude, or your or your altitude. I forget the third one. But so the airspeed has really nothing to do with it. So I would say is not. 35. The most accurate stall warning systems measure the blank. What would that be? The relative error, or is that the most accurate? I don't know whether we actually were presented that. Measure the airstream. You can't have long answer in here. That is differential from the reference plane of the aircraft. Uh, that measure I'm going to say, the relative wind, the angle of attack. All right. Angle of attack indicating systems for high performance aircraft sense the direction of the airflow above the aircraft relative to the fuselage. Well, there we go with reference plane. I was going to say angle of attack as soon as I saw it, but I thought maybe it was a little different. The most accurate threw me off a little bit, but I can see why it would be the most accurate. This is older. This is an older project that, as you can see, it's still kind of up to date. I guess that's going to be it. All right, I guess it's a short one. Thanks for joining me, and I'll see. I guess I can kick off another one, so we'll see you here shortly.